4E, Additive Identity and Inverse. In mathematics, an identity is a number that does not change the other value as a result of the operation. So if we're dealing with an additive identity, the identity is a number that when added to the original number gives you the original number as the result. So in addition, obviously that number would be 0. The additive identity is 0. If I take any number A and I add 0 to it, the result will be A. So that's the additive identity. Any number with 0 added to it gives you back that original number. 5 plus 0 is equal to 5, the identity. -2 plus 0 is equal to -2. No matter what number I have, if I add 0 to it, I'm going to get that number back. So that's the identity, not too difficult. Well, what about the inverse? The inverse is kind of the opposite of this. That's the inverse, right? Inverted or chained, the opposite. The additive inverse is the number that when you add it to the original number, it gives you 0. So given any number, A, plus its additive inverse, you will get 0. Notice I didn't fill in that additive inverse. But it should kind of be obvious to you that if I take a number, what number do I need to add to it to make it 0? I need to take the negation of it. So the additive inverse is the negative of the original number. Because remember, that's really just, if you're adding a negative, it's the same as subtracting a positive. So basically, if I want to get 0, I start with a certain number, I want to get 0, subtract that number away. If I have 8 apples, how do I get down to 0? I get rid of the 8 apples. I have 8 apples, I give away 8 apples, now I have no apples. So the additive inverse is just the negation of the original number. 5 plus what will give me 0? 5 plus -5. So to get the additive inverse of any number, just negate it. Change the sign. -4, the additive inverse is +4. +3, the additive inverse is -3. So it's that straightforward that the additive inverse is just the negation of the original number, or change the sign. So we've already been using additive inverses. We did that when we changed from subtraction to addition for signed numbers. If we had a subtraction problem, 6 minus -4. Oh, it's a subtraction of signed numbers. Well, what do? We keep the first number the same, 6. We change the subtraction to addition, plus, and then we change the sign of that. We took the additive inverse and said, okay, the negation of -4, the additive inverse of -4 is +4. And that's how we got the result. We just didn't call it an additive inverse, because that was a big fancy term that would throw us off when all we needed to do is change the sign. So we've already been using additive inverses. If we want to change from subtraction to addition in a signed number problem, then we took the additive inverse. -5 minus 4 equals, oh, that's a subtraction problem, signed numbers. We want to change it to addition, negative 5 plus the additive inverse of 4 is negative 4. Then we find that, oh, negative 5 plus negative 4, signs are the same, we add them, 5 plus 4 is 9, keep the sign, negative 9. So that's using the additive inverse. Now, sometimes we denote that by using parentheses, and that's why I use the term negation. If we have 4 as our original number, then the negation of that we could say is the negation of 4. This sign out here, we're negating it, we're finding the inverse of it. Right? So the negation of 4 is negative 4. So that's negating what's inside. Well, why is that important to realize that's negating it and just changing the sign of what's inside? What happens if we have the negation of negative 4? Negation of negative 4. Notice now we have a negative in there and we have a negative out here. It would be very confusing to put negative 4. I go, what is that? I don't know, I don't want to deal with it. Okay? That just looks wrong. But the negation negative 4, oh, that means we're going to change the sign of what's inside, giving us positive 4. Now this is different than absolute value. Remember, absolute value just took away the sign. Negation changes the sign. If you have the absolute value of negative 4, that's equal to 4. If you have the absolute value of 4, that's equal to 4. It just drops the sign. Whereas if you have the negation of negative 4, that's positive 4. If you have the negation of 4, that's negative 4. So negation changes the sign. Absolute value eliminates the sign. So let's do a little bit, do some simplification of this. If I give you negative 12, simplified, that becomes the negative of negative 12 is positive 12, right? It changes the sign. Negative 3, negation of positive 3 is negative 3, or the additive inverse is negative 3. Negative 3 plus 2. Well, now we're taking a negative 3, we're not subtracting from something. What's going on here is the negation. Well, negation of 3 plus 2, well, we can go 3 plus 2 is 5. The negation of that is negative 5. Or, we've dealt with the distributive property. Couldn't we distribute that negative 3? We've got this negative outside parentheses. So if we use the distributive property, couldn't we say that's negative 3 plus negative 2? Negative 3 plus negative 2, signs are the same. Add them, 5, negative 5. So it's pretty cool how these different things come together and you start looking at one thing and go, well, wait a second, that's just what we did in this part here. Or we've already done that before, we were already using it. Additive inverses, we were already using when we were subtracting sign numbers. So there's not a lot of new stuff that you see, it's a lot of reuse of things, or things that you've been using that you just haven't had a term to define what you were doing. We called it change the sign. In reality, you were finding the additive inverse. So we put all sorts of fancy names with what otherwise are relatively simple tasks.